It is a very good question on instantaneous rate of change. Let's go through it. Use the difference quotient to determine the instantaneous rate of change in f of x equals to x to the power of 5 at x equals to 1, right? So it is, the degree here is 5, okay? Now, there are a couple of things to learn here. First, let's start with difference of quotient. I hope you remember what is difference of quotient. So we say instantaneous rate of change. Let me write this as this equals to, by definition, it is f of x plus h minus f of x over h, right? Where h is approaching 0, right? But h is not equal to 0, right? We say for all practical calculations, h is very, very less as compared to 1. So these are different ways of writing, and that is called restriction because you cannot really divide by 0. Okay, so when you plug in this function here, so f of x plus x to the power of 5 we have to use here, what do we get? We get here x plus h to the power of 5 minus x to the power of 5 over h. Is that okay? Now, next step is to expand this. So do you remember what is the expansion for this? Well, that's very difficult to remember. So we take help of Pascal's triangle. So Pascal's triangle is something like this. If you don't know, it's a good time to review or to know that. So you start with number 1 and then you start forming a pattern, and on diagonals outside it is always number 1 and inside it is sum of the previous two values. So 1 plus 1 is 2, right? This is a square plus 2ab plus b square. I'm just telling you, like a plus b whole square would give you that, okay? Now we just continue, and the next time what we get is expansion for cube, right? So this is like kind of saying a square, 1 plus 2 is 3, and this is also 3, and this. So this will give you expansion as a square plus 3a cube, sorry. A cube plus 3a square b plus 3ab square plus b cube, right? Now we go further and we get degree 4, and then the next will be 5, right? So when you add it, we get this as degree 4, and next time when you add it, you get the expansion what we are really looking for, right? 1 plus 4 is 5, 6 plus 4 is 10, which is 10 here, 5 and 5. You'll find this is also symmetrical. Do you see that? There is a symmetry here. So we'll use this to expand h plus x plus h to the power of 5. So we get this as, so let me draw a long line here. So x plus h to the power of 5 is x without any, with coefficient as 1. So this is x to the power of 5 plus 5 x to the power of 4 h plus 10 x to the power. So these powers reduces and that power increases, but their sum should always be 5, okay? And then again 10 square h cube, right? Do you see the symmetry also? And then 5, and then this, so h to the power of 5, okay, over h, correct. So, sorry, and then this minus x to the power of 5. Let me write the last term, which is most important here. So this first half is the expansion of x plus h to the power of 5, and then we have minus x to the power of 5, right? From, if you simplify this, x to the power of 5 and x to the power of 5 cancel out, right? 0. And from here, you can take h common. Is it okay? So once you take h common, so you get 5 x to the power of 4 plus 10 x cube, and h is taken outside, so we are left with 1h, and then plus 10 x square h square plus 5 x h cube plus h to the power of 4, okay, divided by h. And now you will see that this h in the numerator and denominator can be cancelled, right? and we are left with all these terms. Since h is very very small to 1 and it's very approaching 0, these terms will be significantly lower, very very low, and so we say approximately instantaneous rate of change is 5x to the power of 4, right? So that is our instantaneous rate of change at x equals to 1. Sometimes the question is asked that write to 3 decimal places or 2 decimal places. In that case, we consider this term also because that gives us to 3 decimal places, right? Well, like for example, if I say h is 0.001, so the answer will be, I'll have to write 1 for x, multiply by that number, so I get 0.001, right? So since that is not specified here, we'll assume that h is approaching 0, so this term is also approaching 0. So all these terms will approach 0 as h is approaching 0, right? And so we are left with 5x to the power of 4, correct? Now, the question is determine the instantaneous rate of change in f of x at x equals to 1. So now, this is general at any point, right? X could be anything here, x is all real numbers. So we can write now here that instantaneous rate of change at x equals to 1 is equals to what? 5 into 1 to the power of 4, which is 5. Okay, so that's our answer. Correct? I hope you understand how we did it. It's important to know this, right? So this helps you to expand these kinds of functions, otherwise you can get stuck. I hope you appreciate it and you find it easy to do now problems like this. Thank you.